Now we generated the ANOVA table by setting up the formula ourselves one by one. We need to be able to do that. But there is another way to generate the ANOVA results, and that is using data analysis. So you go to data, then data analysis. Okay, now if you go to the top, you'll see there are three commands: ANOVA single factor, ANOVA two-factor with replication, ANOVA two-factor without replication. We look at these two later. First, we're going to use ANOVA single factor. Okay, then input range, and it allows for labels in the first row. So go back up, starting from the labels. Let's highlight the entire data set. Okay, now make sure that you check labels, and alpha is 0.05. And let's put the output starting from here. Okay, click OK. Now that will generate our output, and let's do some formatting to clean it up. Okay, so, and the number of decimal places here. And it is the same numbers like what we had from here. Okay, so now we want to test the hypothesis whether the means are all the same or not, and we can do this test using F critical value. So we compare the actual F value with the F critical value. F critical value is from the table. So here F calc, okay, I'll get F calc from here. Now F table value is given by F dot INV dot RT. Okay, remember F distribution is always one-sided. The probability for testing, we assumed alpha of 5%. So alpha is the first one, and then the 2 degrees of freedom, the numerator degrees of freedom, comma the denominator degrees of freedom. So that will give us the F table value. Of course, that F table value is what Excel data analysis also generates that. Okay. Now the conclusion is, since F calc is greater than F table value, we reject the null hypothesis. So we reject the null hypothesis, and we can do the same test using p value also. So p value is given by F dot dist.rt, okay, of the F calc, comma the 2 degrees of freedom. So we already did this here. Okay, so we could simply use equal to that cell also. We can do it that way. And data analysis also generates p value right there. So it's the same value. Okay. And once again, of course, the conclusion here must be the same as here. So these are two different ways of doing the same thing. So using the p-value approach, then, since p-value is less than 5%, the alpha value, we reject the null hypothesis. And then we have to do a interpretation. Now we need to interpret, that is, we do have sufficient sample evidence to conclude that the production per week for the 3 different methods are not all the same. And the probability that that conclusion is wrong, which is the probability of type 1 error, is 0.38%. So here is the interpretation for the results.